Hello everyone, welcome to the project Stock Price Trend Forecasting using Supervised Learning Methods. The goal of our project was to examine different forecasting methods and techniques to predict the future stock returns based on the previous value and also on the user generated data like those of Twitter and the tweets of the people itself. So the reason why our research is important is because the stock market plays a very crucial role in all of our lives, and as it very directly affects our economy, and economy can of course affect our comfort of living. So there have been various attempts to understand this, and we would be presenting our step forward in this direction. So our methodology starts with some data pre-processing and cleaning, followed by feature extraction, Twitter sentiment analysis, and then we move on to data normalization, and then we analyze the different supervised learning methods to try to derive the conclusions. Now, in pre-processing of the data, what we do is we try to combine different data sets and fill in the missing values using different techniques. So the structure of our data consists of we using the historical S&P market index data. These consist of open, high, low, close values of the stocks, and for each company and for the S&P indexes. Along with that, we were using a few other parameters of the company like the investment and the capital and etc. So the next phase was feature selection. In this phase, what we wanted to do was we wanted to prune out a lot of features, because we had a lot of features and we wanted to avoid overfitting and problems of multicollinearity. So we used a select k based algorithm. What it does is it basically gives the k highest values, k highest scores. Now you may ask like how these scores are calculated, right? So for that, F test is done. Basically what it does is it compares the significance of adding a variable to a model with respect to the addition of with respect to the previous model itself. So basically it follows 3 steps. There is one model, say M0, and then we try all the possible models M1 by just picking one feature according to the F statistic, and then we move on, picking in the similar way we try picking up more features. So in this phase, we added a new feature for Twitter sentiment analysis. These give a sentiment score for the tweets that the users give about the company. So now we have a look at the American Airlines stock data that we used. As you can see, the data that we have used is from the inception of the company, which is from 2005, and we have normalized a few features like the open, high, close values. And so let's look at the models that we used. We basically used 6 models, and we primarily wanted to focus on Ansible methods because they are known to perform well. And so we gave neural networks a try along with the Ansible methods of bagging regressors, random forest regressors, gradient boosting regressors, adder boost regressors, along with a conventional regressor of k-neighbor regressor. So let's go ahead and run the code for the American Airlines dataset. And so here we see the data that is being split and the regressors that are being run. So clearly you see the random forest bagging approach is being done, and let's have a look at the results. So in the result slide, we see that on the plot we see the green value is the actual value, with the blue dotted line being the predicted value. So we obtain a RMSE value which is pretty low in orders of 10 to the power of -7, along with a pretty healthy score, R-square score of 0.90 for adder boost regressors. And for gradient boost regressors also, we observe that the actual and the predicted values are pretty much in unison, along with the RMSE value again being in the range of 1.275, but this performing a little better than the adder boost regressor. And clearly the R-square score for this is also 0.961, so which is also very healthy. So then we have a look at bagging regressors. In this case also, we see that with using bagging and boosting, similar results have been found. For bagging regressor, we find the R-square and the RMSE values to be a little inferior as in comparison to the gradient boosting regressors, because the R-square value is a little less than that of gradient boosting, with the RMSE value being a little larger. And clearly, as we see as expected for k-neighbors regressor, we see that the RMSE value is very high, along with the R-square value also being sufficiently in the negatives, being very, very poor regressor, as can be clearly seen from the plot. And we now come to random forest regressors, one of the very famous regressors. In this also we find the RMSE values to be in the 10 to the power of -7 range, along with the R-square value to be around 0.956. So the gradient descent regressors basically use gradient descent approach along with boosting. And the bagging regressors, they use bagging, which is basically just bootstrap sampling. And basically what they do is they use many independent based learners to try to decrease the error. So here we see a comparison between the two. In bagging, each model, since in Ensemble it consists of a lot of models taken together to predict a model. In bagging, each model is built differently, whereas in boosting, it follows a sequential manner. So in boosting, what we do is we try to decrease the bias instead of the variance in the data, whereas in bagging we try to decrease the variance. So of course, and very famous example of bagging is the random forest, and for boosting is gradient boosting regressor, as we have used in the previous slides. So these are the few milestones that we went through in accomplishing this project. Thank you for watching.